hate that teacher and I hate calculus.
Everyone needs an understanding of basic calculus, whether they like it or not.
Why?
For some time now, it is seen that math and science are under siege by those fighting for the cause of equality. As strange as that sentence may sound, with many people online suggesting that an arithmetic problem as simple as 2 + 2 equaling 4 is somehow oppressive.
فکر نکن. نمیخواد فکر کنی. 2 با 2 5 میشه.
Social media is, of course, always a dumpster fire, but things become more disconcerting when this push against math and science bleeds into the real world, as it has been for a while. In 2019, a draft of a framework for K-12 math ethnic studies curricula for Seattle public schools made waves online. And although it's certainly not the most disconcerting thing going on in Seattle, I think it's important to bring up. The key features of this framework, designed to teach math to young people, were focused not on calculation and arithmetic, but on the origins, identity, and agency of math and mathematicians, such as learning that mathematical theory and application is rooted in the ancient histories of people and empires of color. Power and oppression, which focuses on the supposition that empiricism and objectivity are a Western expression of mathematics and are not the only way of knowing, and that to treat it as definitive is somehow disenfranchising to certain people. It also focuses on a history of resistance and liberation, which describes access to math as an act of liberation in and of itself, and reflection and action, which is designed to foster a sense of advocacy and empowerment. If you noticed, there's nothing actually related to math in any of those themes, much as with the recent push for 2 + 2 to equal 5 in complete, albeit hilarious, obliviousness to George Orwell's 1984, the Seattle framework emphasizes the idea that there's no such thing as a right or wrong answer, and the pure notion of rightness and wrongness in math is evidence, in their opinion, of Western colonialism.
Desegregation ruined the American school system.
The Smithsonian National Museum of African American History and Culture was embroiled in a somewhat related controversy after the publication of this infographic that similarly seems to suggest that science, objectivity, and even the concept of time are all aspects of white culture and white culture alone, and thereby a part of Western colonialism, imperialism, and presumably white supremacy. Specifically, the graphic notes that the scientific method, including rational, linear thinking, cause and effect relationships, and quantitative analysis, are all somehow inherent to whiteness. Protestant work ethic and individualism were also castigated as exclusive to white culture, such as self-reliance and hard work. Again, time is listed here as oppressive, including concepts such as planning for tomorrow, which by the way is a key component of IQ, and being able to follow a simple schedule. Moreover, being able to make decisions and just not being aggressive, according to the Smithsonian, are representative of whiteness. Now, I don't know about all of you, dear friends, but I don't think I could find such a comprehensive visual representation of the soft bigotry of low expectations as this infographic, which I should note, being produced by the Smithsonian, is likely paid for in majority, about 62% of which, from federal funding, which as of 2020 equates to about $1 billion per year. This means that your tax dollars are at work to propagate the idea that white people, and apparently only white people, are capable of objectivity, scientific rationality and analysis, working hard, being able to tell time, engage in forward thinking, or even making decisions. Gee, I can't imagine why Trump would want to cut government funding for such a thing as he did in his ban on critical race theory in the government. Not everything, though, does come from the government so directly, as teachers are very often, if not most frequently, the vectors of this type of information and relate it to their students, as did one 6th grade teacher, Zakia Jarrett, in June of 2020 after telling her students that the majority of cops are racist. While Jarrett was placed on leave for her comments, she's just one example of an increasing trend in education for teachers to have an overtly political bias in their teaching practices. The Milton Educators Association collected more than 400 signatures in protest of Jarrett being placed on leave. And while this is just one isolated incident, it's evidence that talk of race, such as that suggested by the Seattle curricula or the Smithsonian, is becoming increasingly common outside the university's ivory tower. For adherents of the idea that 2 + 2 should be allowed to equal 5 because mathematics is in some shape or form oppressive, and the claims of which range from white supremacy to transphobia to colonialism. They argue, as do the progenitors of the Seattle Math and Ethnic Studies framework and the Smithsonian infographic, that objectivity, rationality, and science itself are all oppressive. I would argue instead that in teaching such things, these pedagogues instill in their students a fear of mathematics by priming them with information that suggests they cannot be competent in math or science due to some inalienable aspect of their nature, be that their race or their sex. It implies that math is inherently at odds with some people, and I would fear that that may lead to self-fulfilling prophecies. And I don't believe so in a vacuum. I have data to back it up. Thus, to test my hypothesis that this is a bad bunch of ideas, let's look at math anxiety and demographic differences, as well as the effect that stereotypes have on student learning. And because today's video, like probably most of my videos if that yellow monetization icon is any indication, is likely to offend some people even though it's sincerely not intended to, it's sponsored by a service that allows you to search for spicy things online without worrying about your browsing privacy. That's Surfshark VPN. Surfshark allows you to easily and quickly connect to servers around the globe, both through their application and their handy browser extension, so your internet browsing is safe, secure, and most of all private. Surfshark includes a true incognito mode in their blind search function, so your searches display only purely organic results, allowing you to surf the web with no ads, no logs, and no trackers. Surfshark's unique hacklock feature will also tell you anytime that your email address or passwords have been leaked online, so you can take preventative measures to protect your personal data. In addition to keeping your searches and accounts safe, Surfshark allows you to change your IP address so you can access content not available in your region. If you're in the US, you can't catch classic British sci-fi shows like Red Dwarf or Doctor Who, although I'd avoid some of the later series of Doctor Who. But with just a click of a button, you'll have access to all of your favorite shows. If you're not in the US, great American TV comedies like Parks and Recreation or 30 Rock are unavailable. But if you want to go to there, access is just a click away. If you check out the link in my description and use the code AYDIN, that's AYDIN, you'll get 85% off a 2-year plan with Surfshark, plus 3 months of extra service absolutely free and a 30-day money-back guarantee so you can try it out, and if you find the service isn't for you, no problem, but I just think it might be. So click the link below to check out Surfshark VPN and open up a world of content without getting anxious about anyone snooping on your browsing history. And speaking of anxiety, let's begin by looking at math anxiety. When someone tells you that they're anxious about math, your first reaction might be to think that that person's just bad at math, but that's not always the case. Math anxiety is not simply a description of low mathematical capacity, meaning that when people have poor skills at math, they feel more anxious about them, but rather when math-anxious individuals are faced with a math task, they experience more worries, often about performing poorly on the math problems, and these worries consume the cognitive and reasoning resources that are needed for the task at hand. This means that people who are often highly capable of completing mathematical quandaries may feel so anxious about their performance that that person may not be able to perform competently at the task. We can actually see how these differences in individuals manifest themselves in scans of the brain. Young, Wu, and Menon 2012 utilized fMRI technology to assess differences in activation in certain areas of the brain in students between the ages of 7 and 9 when exposed to math problems. They found that when thinking about math, not only do young students high in anxiety experience greater activation in the areas of the brain associated with processing of negative emotions, such as the amygdala, they also express decreased activation in brain regions associated with working memory, such as the dorsolateral prefrontal cortex and the posterior parietal lobe. Moreover, in comparison to those low in math anxiety, math problem solving in the high math anxiety groups were associated with significantly greater activation in the right amygdala, further spreading into the anterior hippocampus. Compared to young people with low math anxiety, those high in the measure displayed greater connectivity between the right amygdala and multiple regions of the brain associated with social and generalized anxiety. However, the effects of math anxiety were unique. While I could go into more detail about the differences in specific areas of brain activation, I'm not sure you guys are so interested. So in total, the results demonstrate that math anxiety in children is associated with significant differences in activation of brain areas that mediate effective and cognitive information seeking that is unique to math anxiety. That means these differences were specific to math anxiety compared to other forms of anxiety. Both the high and low math anxiety groups in this study did not differ on measures of trait anxiety, indicating that the behavioral and brain differences observed are a product unique to math anxiety rather than generalized anxiety, although some of the same areas of the brain are activated. Differences in brain regions activated during math processing in individuals with different degrees of math anxiety was also assessed by Lyons and Baylock 2011. As expected, their data indicate that those high in math anxiety were more likely to make errors on tests of mathematics, but not verbal tests. They found that individuals who were higher in math anxiety experienced increased activity in the frontoparietal regions of the brain when they believed they would have to perform a math task. However, this apprehension mitigated math performance deficits. That is, those with greater activation in the frontoparietal regions who held some math anxiety were still able to competently perform math tasks. A second study revealed additional differences between activation in regions of the brain in those low and high in math anxiety. Once again, in those with high math anxiety, certain areas of the brain were active during mathematical tasks compared to those with low anxiety. Specifically, there was a negative relationship with activation in the right dorsomedial caudate and the left hippocampus. Those high in math anxiety who activated this network more when thinking about math questions almost completely eliminated their math deficits. A third analysis found that right caudate task activity was positively correlated with activity prompted by math cues in all 5 frontoparietal regions.
This is gold!
Hey, forget about the techno talk. No one's really interested in it.
In total, these data indicate that people with math anxiety are as capable of performing math tasks as those low in anxiety. However, different areas of the brain are active in those with said anxiety. This means that on a basic level of cognitive capacity, those who are nervous about doing math are not inherently less able to do math than those with low anxiety, but that their brains functionally respond differently to math than those who don't possess that anxious tendency. Given that some, but not all people with high math anxiety simply process math problems differently from those low in the trait, it is unsurprising that even when all things are even, those with high levels of math anxiety fundamentally process math differently, as data from Maloney et al. 2010 illustrate. In this study, participants were asked to quickly state how many squares were depicted on a screen, ranging from 1 to 5 squares, and then they were asked to repeat a list of letters presented to them backwards. Those high in math anxiety had a decreased response time on the 2 tasks, and were more likely to make errors than those low in math anxiety. Being asked to simply count the number of squares on a screen or repeat back letters are only tertiarily related to mathematics, but instead indicate that math anxiety represents an obstruction to processing on the most basic level. The researchers suggest then that math anxiety actively impairs working memory, which makes it difficult, if not impossible, to complete higher level functions when one is incapable of completing the most simple units of processing due to this anxiety. As someone who used to suffer from some pretty severe math anxiety myself, and still do to a degree, I can personally confirm this problem, as almost always I would review my work to find errors at step 1 and thus subsequent incorrect results down the line. Thus, people high in math anxiety may struggle to complete basic mathematical tasks, making advanced math often seem impossible. This may be in part due to how those high in math anxiety experience and perceive of numbers differently, in that their comprehension of digits tends to be a bit fuzzy, as described by Maloney, Ansari, and Fogelsang 2011, in their assessment of math anxiety and understanding the distances between places on a number line. In their first experiment, students were asked to quickly press a key to determine if a number displayed on the screen was higher or lower than 5, the numerical standard. For those both high and low in math anxiety, it took slightly longer to determine if a number was smaller or larger when that number was closer to 5, so 4 or 6, than numbers further away from the standard on a number line, so 1 or 9. However, response times for those high in math anxiety were consistently longer than those low in math anxiety. In a second experiment, participants saw 2 numbers and were asked to determine if one was larger or smaller than the other. Once again, those higher in math anxiety took more time to determine where the number fell in comparison to others on a number line. But response time increased as the distances between the 2 numbers also increased, to the point where the differences in performance between those high and low in math anxiety were negligible. These data again indicate that when people have high levels of math anxiety, their basic ability to comprehend mathematical concepts and relationships is debilitated. Not only is math anxiety related to decreased capacity for performing basic mathematical functions or even thinking about numerical values, it also, somewhat predictably, makes those who suffer from it feel less confident in their own performance and express greater difficulty in tasks that are not even directly related to math, as seen in data from Ferguson et al. 2015 across a series of studies. In the 3 studies in which it was assessed, math anxiety was negatively related to a sense of direction, which in this case was measured using questions about one's ability to read maps or judge the distances between objects. These data indicate that those who feel anxious about math also feel less capable of completing spatially oriented tasks. When assessed separately, spatial anxiety reduced the relationship between math anxiety and the sense of direction, indicating that it's because math anxiety creates anxiety about spatial differences that in turn reduces the capacity for those who are high in math anxiety to feel confident about their ability to determine differences in distance or navigate maps. Being able to use maps or determine distance, however, are measures of a distinct type of spatial processing, large-scale spatial processing. In contrast, being able to conceptualize of space using, for example, a pen and paper is considered small-scale spatial processing. A 3rd study in this set indicated individuals, in this case college students, with math anxiety tended to perform less competently on behavioral instruments of small and large-scale spatial processing. A 4th study replicated the 3rd in a sample of adults and found similar results, but this time also assessed differences in gender and found individuals with math anxiety performed less competently on instruments that measured both small and large-scale spatial skill. When gender, general anxiety, and spatial anxiety were taken into consideration, there was no relationship between math anxiety and sense of direction, meaning that anxiety is not responsible for decreased ability to navigate. Of course, it's also just some empirical evidence that women are bad with directions, so who knew?
Their lack of spatial awareness makes them really careless. You should never ever let a woman drive.
Overall, these data indicate that math anxiety is related to spatial anxiety. Thus, those who struggle with math out of fear may also struggle with spatial questions. And yes, then there is some evidence that the differences in people's skill in navigation is perhaps partially due to gender differences. But just because 2 things are related do not mean that they are deterministic. These data could instead be interpreted such that improving spatial understanding may itself reduce math anxiety, and thereby increase potential performance in mathematics. As one might expect, math anxiety and its related influences on the ability to complete math-related and even seemingly non-math-related tasks also has an effect on grades and standardized test scores, as seen in a study from Andrews and Brown, 2015. But just how strong is that effect? In this analysis, test scores, grades, and math anxiety of US freshmen was measured, both on the SAT and ACT, found that lower math scores were related to math anxiety. Specifically, there was a moderate negative relationship between standardized test math scores and anxiety regarding learning math, as well as a weak but significant relationship between math evaluation anxiety and test scores, with both learning math anxiety and math evaluation anxiety being subscales of the total math anxiety instrument. The researchers found that students who placed in more remedial math courses, such as pre-algebra as freshmen in college, and yes, I guess you really can't avoid taking pre-algebra until college somehow, also tended to have higher degrees on both dimensions of math anxiety than did those who placed in more advanced courses. Specifically, the average level of learning anxiety for students placed in pre-algebra was 2.7, compared to 2.2 for students who placed in algebra. There were also differences in levels of math anxiety related to the grades earned in freshman math courses. The average level of learning math anxiety for students who earned an A in pre-algebra was 2.52, compared to 2.23 for those who earned an A in algebra. Similarly, those who failed pre-algebra had an average math learning anxiety of 2.78, compared to those who failed algebra, who had an average math learning anxiety of 2.48. Overall, fewer students tended to obtain A grades in the easier pre-algebra course than in other freshman math classes, suggesting a negative relationship between math anxiety and the final grade in a math class, but particularly in the pre-algebra course, wherein students tended to have higher levels of math anxiety. To put this into perspective and what all of this means, is that when people have math anxiety, they will perform less competently in math coursework even when they are in a remedial math class. For this reason, rewriting mathematics in an attempt to support supposedly different ways of knowing, as those promoting the idea that 2 plus 2 could equal 5 seem to be doing, is no different than the failed attempts of No Child Left Behind. pushing students ahead while their anxiety continues to stand as a barrier towards their comprehension. If a student high in math anxiety struggles in pre-algebra, how disastrous would the results be to take that same student and drop them into calculus, just because they were able to explain their answers, no matter how wrong that answer is.
But even under the new Common Core, even if they said 3 times 4 was 11, if they were able to explain their reasoning and explain how they came up with their answer really in words and in oral explanations, and they showed it in the picture, but they just got the final number wrong, we're really more focusing on the how.
Let's just say, if that's the standard being proposed, we're going to end up with some interesting solutions to scientific and mathematical problems.
Brando's got what plants crave.
While so far we've looked mostly at students, teachers also play a role in math anxiety, as seen in research from Baylock, Gunderson, Ramirez, and Levin 2010, who looked specifically at the effects of female teachers' math anxiety on the math anxiety of their female students. Given that 90% of elementary school teachers are female, if female teachers have a negative impact on girls' math anxiety, it would put girls at an overwhelming risk for future poor performance in math. In this study, female first and second grade teachers were tested for their existing levels of math anxiety, and in turn, the math anxiety of their students over the course of a year. At the beginning of the school year, girls' and boys' achievement scores on math did not differ significantly from one another. However, by the end of the year, the higher a teacher's math anxiety, the lower girls' personal math achievement. This effect was not present in male students. Further, this was not due to the female teacher's math anxiety exclusively, and was mediated by girls' personal beliefs in gendered ability differences in math, such as believing that girls are simply not as skilled at math as are boys. That is, girls who believed that their gender was inherently poor at mathematics received lower grades than did those who did not possess such a belief. The same tendency was not present in boys, in that believing boys receive higher grades in turn was not related to elevated grades in male students.
Still at a reasonably low level of education, her brain suddenly overloads. She cannot take in complicated information.
This explains why girls are less likely to go into STEM then, right? The teacher's anxiety transfers onto them, and this makes girls less successful in math and science. Well, no, not really, so let's address the common belief that girls struggle compared to boys due to social pressures or norms or the patriarchy or what have you. As research from Odea, Lagas, Jenians, and Nagakawa 2018 found that unlike the persistent differences in math achievement seen across racial groups that we looked at in the SAT and other standardized scores, the genders tend to be fairly even when it comes to grades in STEM courses. Not only do girls both in grade and high school, as well as at university levels, perform significantly better than boys in non-STEM classes, they actually slightly outperform boys in STEM as well, although the standard deviation of their scores was much more narrow. This means that boys tend to perform both the best in STEM courses and the worst, and while girls perform better on average, there are fewer girls who score up with the top percentiles of boys in STEM work. Taken together, these data indicate that just because one group may be more prone to math anxiety does not prevent that group from performing well on standardized measures of academic success.
I do well on standardized tests. What? I can't have layers?
It may not be the case, though, that girls consistently have higher math anxiety than do boys, as data from Ahmed 2018 illustrated. While given that girls may adopt some math anxiety from their female teachers, the female youths in this study were as likely as male youths to experience either high or increasing levels of math anxiety. This means that girls are not more likely to have high levels of math anxiety in comparison to boys, but instead that the genders tend to be fairly evenly distributed. In contrast, there were differences between racial and ethnic groups. Specifically, both Black and Hispanic young people were more likely than white students to possess increasing or consistently high levels of math anxiety. On the topic of parental education, which we'll get more into in another video, the children of parents with high school level or lower levels of education were more likely to be prone to have increasing or high levels of math anxiety. The correlation between math anxiety and career choice was also assessed, and these results were indicative that adolescents consistently low in math anxiety were 7.4 times as likely to find a job in STEM compared to those consistently high in math anxiety. Those whose math anxiety decreased over time were similarly 6.4 times more likely to work in a STEM field than those consistently high in the trait. Thus, even though women may inherit a level of math anxiety from their teachers, and I believe we could surmise that other groups may as well, this does not make girls more prone to math anxiety overall. and as a result, it's not math anxiety that keeps women out of STEM. We could also argue that given their consistently higher grades than boys, it's unlikely that lower scores in math are preventing women from entering STEM either, and therefore probably don't prevent other groups as well. As such, to imply some type of systemic inequality in the school system that fails women and girls as well as black and brown people, at least as a product of math anxiety, seems to lack any evidence at multiple levels of assessment. As such, to imply some type of systemic inequality in the school system that fails women and girls seems to lack any evidence at multiple levels of assessment. In comparison, it does seem that math anxiety may be related to decreased trajectories towards STEM positions in some minority groups. Why might it be the case, though, that girls are influenced into feeling greater math anxiety by teachers, yet seemingly are unaffected by that anxiety in outcomes when the same anxiety seems to be so much more deleterious in different racial or ethnic groups? It's possible that groups of people just respond differently to math anxiety, as a meta-analysis of 49 journal articles from Zhang, Zhao, and Kong 2019 indicated. Although the schools assessed in this set were global, including the US, the findings may shed light on how different groups react to math anxiety. Across these studies, the negative effects of math anxiety on grades and outcomes were the weakest in Caucasian participants and the most pronounced in Asian students. That is, while in the US, Asian students consistently outperform any other racial group, they also tend to experience the most harmful effects as a result of their math anxiety. Additionally, the negative link between anxiety and grades was stronger in the studies within this meta-analysis in high school seniors, while the effect was weakest in elementary students. From this information, we can surmise that not only does anxiety compound in its effects on grades over time, it does vary by racial groups, specifically affecting Asian people more than Caucasians. It's important to note that despite seemingly being more affected by math anxiety, Asian Americans still consistently perform other groups in math standardized test scores. Thus, even if Asian people tend to have higher math anxiety, it doesn't appear to overwhelmingly negatively affect their performance in measures of math outcomes. To find more answers on the effects of math anxiety on the Black community, and the notion that allowing 2 + 2 to equal 5 will somehow elevate their performance in STEM, we could look to Chambers, Walpole, and Outlaw. Whoa, what a cool last name, by the way. 2016 for some answers on how math anxiety, or in this case, math self-efficacy, impacts Black women's college enrollment. They found that higher math self-efficacy, that is, believing one's good at math, was related to increased odds of attending a 4-year college, but overall decreased the odds of attending any type of post-secondary institution, including trade school or a 2-year program. That is, Black women who felt confident in their math skills were more likely to attend a bachelor's degree program, but not other advanced degrees. This may indicate that Black women who are confident in their skills in math seek to achieve higher forms of education, as one might expect. One particularly interesting finding is that the odds of attending a 4-year college decreased as family socioeconomic status increases. As surprising as it may seem, for Black women, increased family income was negatively related to actions toward obtaining a bachelor's level degree. This seemingly flies in the face of what we so often hear, in that it's not socioeconomic status that prevents talented Black women from attending a 4-year college program, but that instead, this seems to be the result of individual life choices.
Bummer, don't make fun of grad students. They just made a terrible life choice.
Genetic analysis also confirms that the majority of math anxiety arises from environment, although family background also plays a significant role, as seen in a study from Wang et al. 2014. Mono and dizygotic male and female twins' math and general levels of anxiety were assessed, along with their math problem-solving ability and their reading comprehension. Utilizing univariate behavioral genetic modeling, they found that the additive genetic variance of math anxiety, that is, the degree of anxiety that's attributable to genetics, was 0.43. Given that they found shared environmental factors were non-significant, this means that environment is a more influential determinant of math anxiety than is genetics. This was unique to math anxiety, which was found to be related to general anxiety but not identical to it. Specifically, genetic and non-shared environmental variance related to general anxiety accounted for variance in math anxiety, but was independent from the twins' reading comprehension skills. Additionally, math problem solving accounted for additional genetic variance in math anxiety that was independent from general anxiety, indicating that, again, these are related but distinct variables. To summarize, math anxiety is both genetic and environmental, but percentage-wise, it is a greater product of environment and thereby parenting than it is a genetic propensity. But the levels aren't vastly different. A more recent analysis from Hart and Ganley 2019 examined the various correlates of math anxiety to give us a more thorough look at the relationship between math anxiety and demographic data. They found that the majority of people experience low levels of math anxiety, forming a skewed right curve distribution. This was the case utilizing different methods of measuring math anxiety. Further, both measures of math anxiety utilized in this test were related negatively to math fluency, that's the ability to perform math quickly and easily, and was positively related to general anxiety and test anxiety. Income was negatively, but non-significantly, related to math anxiety. However, income was positively, if negligibly, related to math fluency and generalized anxiety, indicating at best an indirect effect. This means that family income alone cannot be used as a basis for the differences in students' outcomes of math as it relates to math anxiety. There is perhaps an indirect relationship here, but there's no evidence for the supposition that people who are impoverished are more likely to struggle in math due at least to their math anxiety. Moreover, there were no racial differences in general levels of math anxiety. While we've seen before that there is some evidence that Asian Americans may be more susceptible to math anxiety, this study found no such difference. And that also means no major disparity between Black students and students of other racial and ethnic backgrounds. The takeaways from these data are both that math anxiety, which we know is a major contributor to decreased math test scores and grades, is not racially oriented, and also that income is not a major contributor to these differences. Math anxiety also just may not be such a harmful trait all of the time, as Wang et al. 2015 demonstrated when comparing it to math motivation. In their first study, same-sex twins with an average age of 12 and their levels of both math anxiety and math motivation in comparison to their performance on various math-related tasks were assessed. They found an inverted U effect when math motivation was included in the model. That is, when people high in math anxiety also experienced high motivation to succeed at solving math problems, they were just less affected by that math anxiety than those low in motivation. Even when math anxiety was high, students with a strong math motivation performed more competently than those high in math anxiety but low in motivation. A second study found similar but less extreme results in adult undergraduates. Once again, there was a curvilinear relationship between math anxiety, math motivation, and performance, in that even as anxiety increased, those staunchly motivated in math experienced decreased nocent effects. Thus, we've seen that while math anxiety may explain some of the differences in achievement for students of different backgrounds, these findings are not consistent for any race nor gender. Further, we saw that while math anxiety frequently has negative effects on scores on math tests, it's not always the case if one is motivated enough. It's also possible for a group to possess high math anxiety, yet still outperform other groups with lower levels of anxiety, as we saw in the case of Asian Americans. So, understanding the complexities of math anxiety, it can't be so easily pointed to as an explanatory variable for why the education system seemingly fails some students while others excel. Moreover, the evidence of a racial component in math anxiety and its potential effects on the education system are spurious, to say the least. In other words, it's hard to point to race or sex as a determinant factor in why some people struggle with mathematics more or less than others do. Thus, while attempting to help students feel less anxious about math may aid in some outcomes to a degree, alone it seems unlikely to be able to assuage the persistent gaps in test scores and grades that we see across groups. So what about society at large? If we need to decolonize math because it's somehow unfair to Black people, is there a social aspect of education and math that could explain more than math anxiety does? Well, to find out, let's look at stereotype threat and self-efficacy. While we've looked into math anxiety, there's another theory to consider here, and that's stereotype threat. Stereotype threat predicts that people who are in some way stereotyped as being inadequate at math or in other areas of education will in turn experience decreased performances in those areas due to anxiety and decreased self-esteem, leading to self-fulfilling prophecies. In other words, when a group thinks that they are supposed to act in a certain way, the anxiety about not conforming to a stereotype often, paradoxically, leads to stereotype conformity.
I'm getting sick of your stereotypes. Be as sick as you want, just give me a goddamn baseline!
While stereotype threat research has focused predominantly on women, some of it has assessed its effects on ethnic groups as well. an older and very frequently cited study, and by frequent I mean we're talking over 10,000 citations, from Steele and Aronson 1995, provided participants with difficult questions from the U.S. Graduate Record Examination Tests, or the GRE, used for admissions into graduate and doctoral school. Which is a real pain, let me tell you. In both the diagnostic and non-diagnostic conditions, participants were told to expect that they would be unable to answer many of the questions due to the advanced nature of the test. In the diagnostic condition, respondents were told that the test would help them better understand their strengths and weaknesses, while in the non-diagnostic condition, respondents were told that even highly skilled people struggled to answer the questions, but that their skills were not being measured. In a third non-diagnostic challenge condition, participants were only told that the test would be challenging, but also that it did not evaluate their intellectual abilities. Black participants performed slightly less competently than white test takers did in all conditions. But while the smallest difference was present in the version of the test wherein participants were told their intelligence was not being measured, the largest difference occurred in the condition where respondents read that the test was specifically designed to determine their strengths and weaknesses. A second study replicated the first, producing similar results, and also found that Black participants took longer to respond when they thought their intelligence was being measured. A third study had Black and white participants complete words that were missing a letter as part of the GRE test to assess lexical access processing and higher verbal reasoning skills. Race-related activation was assessed when participants finished words that ended with, for example, ACK as Black rather than a word like track, or words that started with WEL with welfare rather than welcome. Self-doubt was indicated when participants finished a word that started with DU as dumb rather than dust or dude, or used the prefix inferior rather than superior. When Black participants believed their intelligence was being measured, they completed more questions with racially related words than white people, or when they did not believe their intelligence was being measured. A similar result was forwarded for self-doubting words, with Black test takers selecting more self-doubting words when they also believed that their intellect was being assessed. Further, Black people who thought that they would be taking an intelligence test reported getting fewer hours of sleep the night before, having lower levels of focus, more stress, and were more likely to view the test as unfair compared to white people in this study. A final study asked some participants to identify their race on the test sheet before beginning the experiment, and were later asked if they thought that people of their race tended to perform poorly or successfully on similar tests, a measure of stereotype threat. Black participants who were asked about their race before taking the test received lower scores than did white subjects, while interestingly, Black test takers received marginally higher scores when they were not primed with the race question. Black participants experienced more stereotype threat, and in a post-test survey indicated they were less interested in sports than white participants were, likely attempting to distance themselves from stereotypes about Black people.
Hey, Lee, you know how to pick a lock, right?
No. Why would you say that?
Well, you're, urban?
Cumulatively, these data indicate that Black people's beliefs about tests actively influence their performance as a form of unintentional self-sabotaging. Being one of the most cited studies in an area of research means it also is one of the most criticized. Scholars, specifically Dr. Paul Sackett and his colleagues, have critiqued Steele and Aronson's work because they controlled for existing SAT scores of their participants, suggesting that the only reason score differences seemed to dissipate in the low-threat condition is because SAT scores were accounted for in the analysis. This criticism suggests that all that was really indicated by these data is that the normal gap between African Americans and whites is exacerbated under high-threat conditions that would not necessarily be present in real-life scenarios. Thus, subsequent research has focused on maximizing attempts at external validity, that is, measuring something that exists in the real world rather than an academic concept. Brown and Day, 2006, attempted to tackle this criticism by providing Black and white subjects with 3 descriptions of a test they were to take. In this case, Raven's Progressive Matrices, a test designed to measure the reasoning component of Spearman's G, or what we colloquially call IQ. Participants read that the test was either an IQ test, representing a high-threat scenario, that the test was used in measuring abstract reasoning and fluid intelligence, which is what the test actually is, and represents a standard threat but doesn't use that scary word IQ, or just a set of puzzles representing low threat. As with the Steele and Aronson study, ACT scores were controlled for, but in this case, only for the within-race groups, maintaining the differences between racial groups. However, raw scores were also provided. African American participants were significantly less accurate than white participants in general, but specifically when the threat was standard or high, but this was not the case when the threat was low. In fact, Black respondents slightly but non-significantly performed better on the test when they were told it was just a series of puzzles. A meta-analysis of research on stereotype threat effects in both women and minority groups from Nguyen and Ryan 2008 may provide us with some greater understanding. Drawing from 76 published and unpublished studies, stereotype threat was either blatant, declaring to the test taker that different groups tend to perform better or worse on the test, moderately explicit, stating that groups tend to perform differently but not necessarily better or worse, or subtle, identifying no differences, but instead priming race or gender identity by asking demographic questions beforehand. Methods of mitigating stereotype threat were also utilized in this study, which included strategies that primed participants with information stating that their race or gender was actually better at the test, or explained the concepts of stereotype threat in the explicit conditions, or more subtly described that the test would not assess performance or that it didn't measure intelligence and instead was just a puzzle. They found that stereotype-threatened minority groups performed more poorly than did minorities not exposed to stereotype threat when those tests were more difficult. In contrast, women performed less competently when the math task was challenging rather than moderately difficult. When the test was easy, women instead saw increased performance on the test. In aggregate, stereotype threat cues had a stronger influence on the performance of minority groups than they did on women, and that this effect was most prominent in the moderate threat cue condition. In an interesting turn, blatant and moderate threat primes, which reminded participants of group differences, both had similar effects on test outcomes, but studies which employed the use of subtle stereotype threat cues actually yielded the largest mean effect sizes. In terms of stereotype threat removal strategies to reduce the impact of stereotyping, these attempts had a stronger effect on women's math test performances than they did on minority groups. Moreover, minority test takers seem to benefit more from subtle and indirect threat removal strategies than from direct and explicit ones. What this all means is that minority groups' potential for stereotype threat is not ameliorated by avoiding information about differences in test taking and demographics. Instead, in something of a contradiction to stereotype threat as an idea, subtle cues produce the strongest effects of stereotype threat for minority participants. Importantly, sycophancy towards minority groups does not appear to aid them in their test-taking skills, and they benefit more from subtle support rather than blatant statements of their own group's superiority. These data indicate that telling people their group is just as good at math does not actually help that group succeed, but also, telling a group that they are just as bad at math is less deleterious to that group's testing outcomes than just letting them ruminate about their own beliefs regarding their group's test-taking skills. In a bizarre twist of what is so often depicted as common sense, telling Black people that they are better at math than other groups is potentially more harmful to their testing outcomes than telling them that Black people tend to underperform. While stereotype threat exists, this may be evidence that people don't like being coddled and that holding them to higher standards creates an anxiety all of its own, perhaps a relative of imposter syndrome, the belief that no one is supposed to be in the intellectual position that they currently hold. This means that programs that adopt anti-science rhetoric, like 2 + 2 = 5, are unlikely to reduce the education gaps that we see consistently between groups, and may instead actually increase that disparity. Another important factor to consider that I've mentioned briefly before is self-efficacy, which is the degree to which one feels capable of performing any given action. Students with high math self-efficacy may take more time to carefully complete difficult math problems, and as a result, tend to be more accurate in their math problem solving than those low in efficacy, and thus efficacy may combat the effects of math anxiety and stereotype threat. Huang, Zhang, and Hudson 2018 examined the relationship between math anxiety and math self-efficacy, as well as career interests in middle school boys and girls. Growth mindset, the belief that one's abilities increase with hard work, was also assessed. You know, that thing that the Smithsonian says is a sign of whiteness. Girls tended to have more math anxiety than boys, but lower math self-efficacy and a decreased growth mindset in addition to being slightly less interested in STEM as a career. As we've seen before, math anxiety was negatively related to interest in a career in STEM. But more in line with our current topic of reducing the effects of anxiety and stereotype threat, math self-efficacy was found to be negatively related to math anxiety. This means if students feel they are competent in math, that feeling alone may supersede the harmful effects of math anxiety. Specifically, math self-efficacy served as a mediator variable between the effects of anxiety and interest in STEM. It also served as a mediator for growth mindset, being more strongly correlated to STEM interest than growth mindset was alone. These results were present in both boys and girls, but math anxiety was less strongly negatively related to math self-efficacy in girls, meaning that girls are potentially less influenced by anxiety in a way that would prevent them from benefiting from math self-efficacy. For boys, more than in girls, growth mindset significantly predicted mathematics self-efficacy, indicating that boys are more likely to feel efficacious when they also believe that hard work will lead to improved performance in math. The power of math self-efficacy is not just related to sex differences, and could be an explanatory variable of racial and ethnic group differences as well. Data from Gwilliam and Betts, 2001. Gwilliam, earlier we had a researcher named Outlaw. Now I feel like me rewatching Outlaw Star is somehow seeping into and warping the reality of the data. They indicated that efficacy does not seem to widely vary across groups of college students from African and European backgrounds. While men reported significantly higher levels of math self-efficacy than did women, and subsequently were more likely to select a career in STEM, the same was not the case for students of different racial backgrounds. In contrast to the differences between the sexes, African American and European men reported comparable levels of math self-efficacy, as did African American and European American women. Correlations between the job duties associated with careers in math and science related to the investigative aspect of self-efficacy, compared with the science-relatedness of both major and occupation choice, were significantly higher for African American females than for African American males or for European American males, meaning that self-efficacy may have a slightly more pronounced effect on job choice for African Americans, but these findings were limited. Math self-efficacy accounted for 18% of the variance in selecting a STEM-related field among male African Americans and 21% in European Americans. These differences were not statistically significant, indicating that African American levels of math self-efficacy was not a determinant in their likelihood to enter science or math areas of work and study. In total, the findings indicated that while there were differences between men and women in math-related self-efficacy, there were no significant differences between African Americans and European Americans of the same sex. This means that Black people in general are no less prone to having high math self-efficacy, believing they are good at math, than are white people. These effects of math self-efficacy are not limited to Black and white Americans, and instead they tend to vary widely by country. As seen in a study of 41 countries participating in the Program for International Student Assessment, or PISA, from Lee 2009. Math self-concept was also assessed, which is the degree to which one is naturally good at math. Despite ranking in 37th place in mathematics in a 2018 PISA assessment, US students had the highest math self-concept, viewing themselves as inherently good at math, while Japan, which ranks in 6th place in math achievement, had the lowest average level of math self-concept. Similarly, Japan ranked lowest in math self-efficacy, while Liechtenstein, which ranked 8th highest in the 2012 PISA rankings of math scores, just one place below Japan, was by a wide margin the highest in math self-efficacy. Similarly, Liechtenstein had some of the lowest levels of math anxiety, with Sweden possessing the lowest. While Tunisia ranked as the 6th lowest scoring nation in the 2012 PISA report on math performance, Sweden ranked 38th that year overall and 17th in math in 2018. Thus, just because a nation is particularly high in math self-concept, math self-efficacy, or math anxiety, it seems to in general have little effect on how that nation actually ranks in math performance. If anything, it seems that countries low in math self-concept and efficacy, namely countries like Japan and South Korea, consistently perform among the best at math, calling into question, again, the true power of math anxiety, math efficacy, and self-concept. Knowing all of this, let's get further into the influence of math efficacy on outcomes so we can put it all into perspective. Griggs et al. 2018 examined the effects of math self-efficacy on interest in math activities, intentions to engage in math courses in higher education, and math achievement in Australian primary and secondary students. They found that prior math self-efficacy did not significantly predict subsequent interest in math or intentions to pursue a STEM education, nor did math intentions predict math self-efficacy, indicating that math self-efficacy is not a determinant for interest in or intent to seek out a career in math, although efficacy was positively related to higher grades in math courses. Instead, initial interest in math predicted intentions to study math further, but this was no longer the case when controlling for math efficacy. Additionally, intentions to study math in higher education was unrelated to grades in math. These findings are all evidence that efficacy alone is not enough to inspire students to seek a career in STEM. They also just kind of have to be interested in the subject matter, which is a bit ridiculous to even have to say. Of course it is. Further, just wanting to be a scientist or mathematician has no relationship with grades. Thus, students need be interested and efficacious to likely go into STEM, indicating that just believing one is good at math alone, or even being interested in math alone, are not enough to inspire a student to become a scientist or mathematician, but rather, a combination of variables seems necessary. Just because math self-efficacy over time, albeit not in isolate, may improve grades, how does it affect test scores? Roik and Ringianson, 2018, sought to answer this question and assess the role of self-regulated learning. Pintrich, 2000, defines self-regulated learning as an active, constructive process whereby learners set goals for their learning and then attempt to monitor, regulate, and control their cognition, motivation, and behavior, guided and constrained by their goals and the contextual features of their environment. In short, it describes a student's ability to learn on their own terms and at their own pace. Cognitive learning strategies, which are establishing relationships between cause and effect within math, as well as metacognitive strategies, which are goal setting and planning, were also assessed. And don't forget that goal setting is one of those things that the Smithsonian said was inherently related to whiteness. Freshmen at a German university were the subjects for this study, and their math performance was traced over the course of a year. They found that using cognitive and metacognitive strategies at the beginning of the year predicted higher self-efficacy levels later in the year. But by the end of the year, efficacy was related to decreased use of both strategies. Moreover, a higher math grade was predicted by the utilization of metacognitive strategies at the beginning of the year, but by a reduced engagement in metacognitive strategies by the end of the term. These results are evidence that if students strive to establish associations between new and existing knowledge throughout their first semester, by utilizing cognitive and metacognitive strategies, they accrue increased math self-efficacy, which in turn seems to redouble their efforts during the second semester and going forward. I know that sounded a bit complicated, so too long didn't watch. Personal goal setting and intent towards learning are an important component of building math self-efficacy, something which no one but students themselves can be responsible in utilizing. And again, which is something that the Smithsonian states is inherently related to whiteness. So with all of this in mind about math self-efficacy and stereotype threat, let's come to a few conclusions. If the point of 2 + 2 = 5 is to somehow decolonize math so that all answers are equally correct as long as the student can explain his or her answer, and reduce the effects of stereotype threat, then maybe, to a degree, the adherents of the movement have something of a point, albeit still a strange and I believe incorrect one. If saying all answers are acceptable, that may reduce anxiety surrounding stereotype threat, in that respondents would likely not feel pressured to answer the questions correctly, lest they live up to self-fulfilling prophecies. However, this inherently does not mean there would be more correct answers, given the entire point is that there are multiple correct answers and only to reduce anxiety by eliminating the concept of objectivity. But we saw when we looked at stereotype threat that that's not always the case, and in fact, going easy on students again can be more deleterious than judging them by the same standards as other students. Would making all answers equally valid so long as they can be explained reduce stereotype threat? Potentially, but only in an educational setting, and that would do nothing to prepare students for the real world where a mathematical error can be catastrophic if, say, one is an engineer or an architect. Moreover, it seems that math self-efficacy can serve as a natural buffer to the negative effects of stereotype threat, and that variables like low math self-efficacy or self-concept and high math anxiety have highly mutable effects based on nation and gender, not just race. These concepts are far from universal and again vary from country to country. Additionally, people of different backgrounds seem to have similar levels of math anxiety, and if we cannot explain away all the differences that we see in education outcomes on race, sex, teaching strategies, or other personal variables like math anxiety or self-efficacy, what we're left with is family background. And again, that's not something that the government can so easily change. But hey, what do you guys think? Do you think that we need more government education programs to try different methods of teaching math? Is math anxiety something that a teacher or school can treat? Is stereotype threat the leading cause for education gaps? And if so, how could the state possibly change a cultural perception? As always, I want to give a huge shout out and enormous thank you to all of my supporters and generous backers on Patreon and Subscribestar. You guys truly allow me to dive into complicated topics like this and report what I find. You all are absolutely wonderful. You can help support the channel by checking out Surfshark VPN, or by clicking one of the links in my description to either sign up for Patreon or Subscribestar, or buy some merch from my store. Finally, if you enjoyed this video, consider giving it a like and subscribing, and as always, dear friends, Altana Volt.